Okay, we're going to be finding the equation to the tangent line. And I've got a nice little picture drawn here. So this curve right here, as you can see, this is my function, and this red line right here, this line here, this is the tangent line. And this is the equation here to the tangent line. And that's what we're going to be coming up with. And we're going to be using the definition of the derivative to find the derivative of this function, and then we're going to find the point on the graph. I think x is equal to 1, and then we're going to derive up the actual equation to this line. Okay, so just kind of repeating myself here, we're going to be finding the equation of the tangent line at x equals 1. Alright, step 1. We want to find m. And m is the slope. So slope usually denoted in earlier courses as m. And then step 2, we're going to find b, and b is the y-intercept. So here's our function, f of x, which is equal to the square root of x. So we want to find m, and we're going to do that by first finding the derivative of the function. But we're going to be doing this the hard way, and we're going to be using the definition of the derivative. So if you don't know the easy way yet of finding the derivative of this function, well, you'll appreciate it, I promise, after doing some of these a few times by using the definition. Okay, so this is the definition considering the limit exists. We denote this as f prime of x, and this is the limit of delta x approaches 0 of f of x plus delta x minus f of x over delta x. So our f of x is the square root of x, so I'm going to take x plus delta x here. See this object, just pretend this is all one solid object here. I'm going to take this, all of this, and move this x out of the way and replace all of this inside underneath the radical, as you can see here. And then we go minus the function, right, f of x all over square root of x. Now if we find the limit doing direct substitution here, we just end up getting 0 over 0. Okay, as you can see. So what we're going to need to do here is we're going to multiply through the numerator and the denominator by its conjugate. So this should look really familiar to you if you've worked some earlier problems in my sections on solving limits analytically. But once we simplify all this down, not sure exactly why I repeated that, but I did. Okay, so we multiplied all that good stuff out. Hopefully you know how to do the intermediate algebra. And we get down to this point here. The x's cancel out, and you're left with a delta x up here, delta x down here. So those are going to cancel out. So we're just left with a 1 on top. And now you can do the direct substitution, plugging 0 directly in for delta x. And we end up, after simplifying this down, as 1 over 2 times the square root of x. We're going to, now I don't guess I rationalize the denominator here, I just leave it as is. But remember, x was equal to 1. So now that we found the derivative, we're going to plug 1 into the derivative and find the slope of the tangent line at 1. And so I do, and that slope of that tangent line is 1/2. Or okay, so we are saying that again here. M is equal to 1/2. The equation of the tangent line is y is equal to mx plus b. So we want to find m, and then we want to find b. So to find m, right, well, that's what we did up here. It's 1/2. Now we just find b, but I must note we need to find y first, right? We got to find y. So I plug 1 into the function, therefore y is 1. So now we're left here, solve for b. So after solving for b, we get 1/2, therefore that's the equation to the tangent line. And there it is.